Hello, this is Sanjay Paul, and my teammate name is one of my teammate name is Dharmik, and the another one is Awaj. Professor gave us to solve a problem, which is car following model, and in this problem, uh, he suggests us to develop a Python code for car following model, and where um, our the value of truck and SUV and sedan is given, and there is another bonus point which is behind the sedan. There will be another car, and its velocities, initial velocities, all of these cars are given, and there is a reference for and this is Zhao and Gao's paper, from where we can find the equation of this car following model. This is conceptual model, where we can see that on the car following model, and this is for our bonus point, and from we took this value from web, where truck length is 80, SUV length is 17, sedan is 15, and another car is 15. This is our mother equation, which is the full velocity and acceleration model. From this equation, here k is chi, it's a constant. Sensibility of drivers. Then this is another equation. Actually, we this equation is mother equation, and this is the previous following model car equation, where Vm is maximum speed and theta is heavy side function, and theta value is for negative it's we consider 1, and for the positive we consider for negative we consider 0, and for positive we consider 1, and proceeding vehicle is I plus 1, and the following vehicle is I. This is the optimal velocity model. From here dv by dt is dv by dt, where k is 0.85 per second sensitivity of drivers, and vs is OV function, as is NATO distance of proceeding car and the following vehicle. Vt plus 1 is velocity at later time, Vt is velocity at previous time, and x is position, and L is the length of vehicle. So from using this Vs, we use this Vs in here, and it's a optimal velocity model function, and Vi, V2, C1, C2, it's all are given. From this we run this code in Python, this function in Python, and we got the result of position and time, where we can see that there is no collision, and the second graph is shown velocity and time. If we see in the first graph, there this truck, actually in our question, this truck at first, this truck's initial velocity was 55 mph, and after 5 minutes acceleration it's going to 60, then suddenly it brakes, and it's for 40 seconds, and that time this truck's acceleration was 40 mph. So actually this shown that time versus velocity of truck, SUV, sedan, and car. This is acceleration versus time graph, where we can see that the truck, SUV, sedan, car its acceleration at 0 time, and we 50 and 50 100. Actually, in our Python code we consider the time for 1 second, 1 second, 1 second, and actually this is our reference of for car following model. We took this function from this, and this paper is given by our professor. Thank you.
Hello guys, we are assigned to work on vehicle difference, velocity difference and acceleration model. Dr. Udameri assigned us as a green team, and we are working on it. As far as we work on it, we let me go through with that. First of all, we convert velocity and distance to the by multiplication of the certain factor. We converted it to mile per hour to meter per second, and distance in feet to meter, and then we defined pi as 22/7, and also there's another parameter given, is the sensitivity of the driver. It can be written as 0.85. Its unit is second inverse. And then let us move forward. Let's define the velocity of truck. I mean by initial velocities of each vehicle. Velocity of truck is 55, which is given, and we multiplied it through the factor, so overall it will be converted to meter per second. The same for SUV, the same for sedan, the same for car. Okay, then let us move to the another step. Here the position of sedan car, that is at the last as 0 0. That means we choose just in front of the sedan car as a datum line. So on the right hand side of the figure it will be considered as a positive, and left hand side of the figure will be considered as a negative. So let's find the distance of each vehicle from the datum line. First of all, let's say distance of truck from the datum line. It can be written as 10 plus 15 plus 25 plus 17 plus 30 plus 80. So here 10, 25 and 30, this is the length of vehicle, and 15, 17 and 80 is the distance between two consecutive vehicles. The same for SUV, sedan and car. The car is showing 0 into the factor because we chose just the front portion of the car as a datum line. That's why it's written as a 0 there. Let's move to another step. Length of vehicles are given already. Its length of truck is 80, SUV is 17, sedan is 15, and car is 15. In the first portion of the equation, there's stated that truck accelerates to a speed of 60 mile per hour for 5 minutes and then reaches to a speed of 40 mile per hour in next 40 seconds. So overall there will be time duration will be 340 seconds. So let's consider T, capital T is equal to 340 seconds. It's a total time. For this simulation, we will calculate value of each equal interval of the whole time duration. It will be, let's take T is equal to 1 second. So let's define del T is equals to 1 second. So we need to import libraries first to integrate and differentiate the equations which we had in our model. So first we import pandas library, numpy library, math library, and for our plotting our graphs we will import pyplot library from matplotlib. let's go to step 2. We will create a function to calculate optimal velocity, because it is the first step of calculation, which will take us to the final equation, which will help us to calculate full velocity and acceleration model. So here's the function name is vs. Define vs, v1, v2, c1 and c2. These all things are given in our model. So, and also optimal velocity equation can be written as vs is equals to v1 plus v2 math 10h math dot radians. Here radians is taken because Python don't understand angle and degree, so we must let Python understand in radians, input in radians, so there will be no problem with the output. So let's move to step 3. We will use for loop to calculate position, velocity and acceleration. So first we will define an integer that's t by del t. It's showing a limit. On that we can multiply with the different portion of variables, so that we can work on it and calculate the amount of different variables on particular time duration. So here's some arrays on which we are working on. So first, acceleration of truck, SUV, sedan and car can be written as this. So it must be in a float for 64. That's why it is decimal values, right? So, and the same for arrays for velocity for trucks, SUV and sedan and car. So they are also a float 64. They all will take value LSD from here. It's a multiplication with an integer which we define at total time upon unit time. Okay. Then we will define on another variable that will be used for a loop, and it is I. So we will define it I is equals to 0, and its range will be from 0 to n minus 1, because it will go up to, not up to n, just before n. That's why. And then we will assign some boundary conditions on the first element of respective arrays. Like for truck, velocity of truck, its first element of the list will be considered as v0tr. So it's initial velocity of truck, and initial position of truck can be written as xotr. The same for SUV, initial velocity, initial position and netto distance. What do you mean by netto distance? It is the distance of the proceeding vehicle and the following vehicle, distance between the proceeding vehicle and the following vehicle. From the conceptual model we can find it. So the same for sedan and same for car. Okay, sir. Thank you.
Okay, further moving into the code, before this point my friend has pretty much explained in the same video. Now we have the for loop, and as he said, the values of in the range, it doesn't quite go up to n. So since we are initialized one value already, we have initialized here. So now in this particular case there are 440 minus 1 values that are to be input. So we go from 0 to 338. So we assign the final value of range as n minus 1, that happens to be 339. And okay, our for loop starts here, and I is the variable that's going to be updated and constantly looping. And when I is less than 300. That is the initial condition of the truck that is been given to us, which says that the truck accelerates up to 5 minutes, and then after that it decelerates 5 minutes, so that we have two conditions. One is within 5 minutes, that's 300 seconds, and one is other condition is after 5 minutes. So we have two if else condition here, and this in this part of equation is like this is the initial velocity like the previous velocity, and here is like this is the slope of the velocity time curve, and the v conversion is the conversion factor. As my friend already told, I plus 1 is the time factor that is being updated constantly in this loop. Similar to this one, here we have like the previous velocity that is at the peak point at when the time is 5 minutes or 300 seconds, and then after that we constantly update the value of velocity of truck in v underscore trk array. After that we have x underscore trk, that is the position of truck. For the position of truck we use the previous position plus change in velocity multiplied by time, with this parameter is the distance that is traveled within that time. Let's say like the distance traveled between t is equals to 0 and t equals to 1. So that's how we get position of the truck for successive times. And for the acceleration, what we do is lateral velocity minus previous velocity divided by change in time. For v SUV, that is the velocity of SUV, we calculate, we give the initial condition as the boundary condition, and this is the equation that comes from our OV function, which chi del t vs OV function and minus previous velocity. Okay, let me quickly show that in slide here. Okay, here is that function that we just used there. This is the chi and OV function velocity that we get by inputting here. In our code for OV function we have a separate function, so basically here we are calling the function itself every time we run this loop. So similarly we calculate the distance of SUV, I mean the position of SUV, by using the average velocity by 2, that's average velocity, change in time, and previous position of SUV. And this SSUV is to record the position of that is to record the net to distance of SUV. That this is the value that we actually need to call the OV function. So that is the net distance that remains in between the previous vehicle and the following vehicle. So that is, for that we have formula that's again given in the paper that we are allowed to use, and that's the position of previous vehicle, which is truck in this case, minus the position of SUV minus the length of truck. So moving further, we calculate acceleration same as the acceleration of truck by using the formula lateral velocity minus previous velocity by del time. Again, for the velocity of sedan we use previous velocity, OV function parameter Vs, for which we have we have S sedan, and again for the initial condition we get the value from the initialization over this part, and we calculate the velocity of sedan successively for all the latter cases. So again, for the position of sedan we follow the same steps like in SUV, and this is like the same for the sedan, and then for the SUV just the just what we are updating is the, in cyclic order, we take the, position of previous vehicle minus the position of the vehicle that is following minus the length of the vehicle that is ahead. So that's being updated till this point. And for the car, this is our bonus part of the problem, and we have combined this together in this video. And this LST, this parameter, is recorded to be presented as time. Since we have to plot a graph, time versus velocity, we have this parameter, it's just recorded as time, so and for here we have this VSUV just to check like if the code is running properly or not. And then again, now we are moving on to the part that plots the value, by using matplotlib. So for that we need to have panda series. We are converting those arrays to the panda series. For the position of truck, SUV, sedan and car, we assign the variable A, B, C, D, and T is again I said like just before, like the time. And this is the code that we actually let's run and see what's the output from this code. So till this point the code runs, and the velocity of SUV at 0 time is 25.48. Now this is just the plot, this is the plot part, and for the plot of position time relationship, this is how we get the position relationship. Here is the velocity appears a little bit clustered, but again we will have to check the datas to find out whether they are like there's actual collision or not. To plot, again we gave the label truck, so that this index appears right here, truck, SUV and sedan and car, so that we know which one is for which. And this time second is just the index, for the index and the x-axis, and for the y-axis we have position and meter. And this is the title, the PLT, the title, this is the command for giving the title to the graph. And then PLT legend, it keeps null, so it gives the null argument. And PLT.show, that means the plot, whatever the instruction, the PLT instruction, this till this point is shown in the plot. And again similarly we do the same for velocity versus time and acceleration versus time. And now we are trying, since I mentioned above, like here the datas, they seem like there's a clustering of datas, and to and the graph of to visualize the graph of velocity time and acceleration time, to this kind of look unrealistic. There is like sudden drop in velocity in all three following vehicles and that are following a truck. So to look more into that data, we are actually trying to save the data to CSV file. This is how we do that. The location is the same location that we have here for the file, and let's go to that location. Okay, that's in the desktop mini project, it's right open here. And let me open, this is the submission. Okay, this is our data, and we can pretty much look into the data and find out why such figure, and maybe inspect in those areas wherever we have any such thing. And again, coming back to the PowerPoint slide, as I mentioned, like there apparently is no collision because we started at different point, different velocities, and this is the result that we obtained after running these codes. This is pretty much for this video. Thank you.